So this is day 2 of statistics. So today we're going to talk about the standard deviation. And the standard deviation's job is to tell you how spread out your data is. Think about it like this. If you've got a set of test scores from your Math 1 class, and the average was, let's say the average was an 85. But everybody's test scores were between an 80 and a 90. Okay, then another class had an average of an 85, but their test scores ranged from a 60 all the way to 100. So even though they have the same average, they have a different standard deviation. Class number 2 was much more spread out than class number 1. So this class has a higher standard deviation, a bigger standard deviation than this class. This class data is much more consistent. It's much more tight around the mean. Okay, so if we apply that to this, the standard deviation describes the spread of the data. The more widely spread the data, the bigger the standard deviation is. The less spread the data, the smaller the standard deviation is. The standard deviation also tells you, and this is just another word for spread, but it's a little fancier, the variability of your data. If your data is very variable, if it varies a lot, then it has a high standard deviation. It's very spread out. So the smaller your standard deviation, the less variable your data is. The larger the standard deviation, the more spread out, the more variable your data is. So a normal distribution looks like this. If I have data that has a small standard deviation, my average, my mean is in the middle of the hump, but my data is going to look like that. If my data is really spread out, then my data is going to look more, my curve is going to look more like this. So this one has a smaller standard deviation, and this one has a bigger standard deviation because the data, there's more data out here in the wings than there is here. This is a little bit of data out here. There's a lot of data out here on the wings. That means it has a big standard deviation. So let's look at the following distributions and see if we can answer the question. What is the mean of the graph of A? Well, the mean, the average, is under the hump, so that would be a 40. What is the mean of the graph of B? The graph of B under the hump, that would be a 30. Which graph has a larger standard deviation? Which graph's data is more spread out? And that is graph B. What would happen to the mean, the average of graph B, if we added a 30? Well, if my average is about a 30 and I make another 30, it's not really going to have any impact on my average at all. So this wouldn't affect the average much at all. Okay? So now let's say we're going to add a 20. If we add a 20, what's going to happen to my average? Well, if my average was a 30 and I put a 20 in here, it's going to pull my average down a little bit. Okay, what happens if I add a 48? Well, if I add a 48, that's way over here. If my average is a 30 and I make a 48 or I put a 48 in here, that's gonna up my average. It's gonna increase my average pretty significantly because that's really far away from the average. Okay, what if I make a 12? If I put a 12 in here, that's gonna really pull my average down. So it's gonna decrease my average. Okay, what would happen to the standard deviation? Now remember, your standard deviation is the spread of your data. Okay, so let's erase this and get back to normal. Okay, so if I add a 30, my standard deviation is actually going to get smaller because 30 is my average. So the more data I put in here, it's going to pull my data closer together. So that's going to make my standard deviation get smaller. 32, it's not much more than a 30. It's not going to have that great of an impact. But now let's talk about a 47. If I put a 47 out here, that's going to spread my data farther out. So that's going to make my standard deviation increase. Same thing with a 15. If I put a piece of data way down here that spreads my data farther out, that's going to make my standard deviation increase. Okay, now let's make sure that we understand the difference between standard deviation and range. Range is very simple. Range is your max minus your min. And I don't care what happens all in here. It makes no difference what's added in here. But it is my max minus my min. So as long as 50 is my max and 10 is my min, then my range will be 40. 50 minus 10. So adding a 30 in here does not affect my range at all. Adding a 15 in here does not affect my range at all. Adding a 49 does not affect my range at all. Now, you add a 55, you've now gone outside my normal range. You put a piece of data out here, my range just got bigger. Because now instead of 50 minus 10, I'm now 55 minus 10. So my range just increased. All right, let's talk about a 6. If I put a 6 down here, and a lot of people say, oh, it's smaller, so it makes your range get smaller. Well, remember, my range was 50 minus 10. My minimum is not 10 anymore. My minimum is 6. So that actually makes my range go up because my range is now bigger. Because instead of just going from 50 to 10, I got to go from 50 to 6. So my range goes from a 40 to a 44. It gets bigger. So if I add data any side outside my normal range, it's going to make my range increase. Okay, so Kyle's test scores are as follows. Okay, Kyle makes a 98 on his next test. Which of the following would be true? Okay, so first things first, let's get our data in order. So let's go 76, 84, 87, 90, 91, 92, 96, and a 103. So those are his normal test scores, okay? Now he's going to make a 98. So 98 would fall about there. So that's our new piece of data. So would this make my mean, my average, increase? Well, think of this as your curve. Your mean would be somewhere in here. If you make a 98, would it increase your average? Well, think about it in terms of test scores for you. If these grades in blue were your actual test scores and you made a 98, that would increase your average. So yes, absolutely. Okay, well, let's not just stop right there. Let's make sure we understand why the other three are false. It says that my range increases. Remember, the range is very simple. It is the max minus the min. So does putting a 98 in here affect the max minus the min? No. My range would not increase. Now the standard deviation is how variable, how spread out your data is. Standard deviation decreases. That means I need to be putting data in the hump. This 98 is not going in the hump. It's going out here on the wings. So it's causing my data to be more spread out. So it would actually make my standard deviation increase, not decrease. IQR, your interquartile range, you cannot tell any information from the curve. To find out about your interquartile range, you have to have a box and whisker because you need Q3 and Q1. So I don't have information for that. So he's out. Miss Patterson's bowling scores for the past month are that. And believe me, that's much better than I normally bowl. If she scores the following on her games this weekend, what can be said about the data? Okay, well, let's put the old data in order. So we're going 170, 192, 196, 197, and 200, 205, and 226. Okay, I'm going to put in a 241. Wow, that's new. A 198, a 162, and a 230. Okay, and all of these sentences have to do about it's being peaked, more peaked or less peaked, and widely spread, either more widely spread or less widely spread, because let's talk about it. So if this is my curve, and I put data here in the middle, that's going to push the peak up. So that makes us more peaked. So less peaked is out. I like the more peaked. I like the more peaked. Less peaked is out. So A and D are out. Now let's talk about our spread. I'm putting data way out there in the wings. So that's going to make it more widely spread. So more widely spread, not less widely spread. He's out. I'm more widely spread because I'm putting data out there in the wings. Okay, we got two curves, normal distribution 1 and normal distribution 2. Now let's look at these curves before we go read these questions. His average seems to be at about a 5. Pretty curve, very nice, symmetrical. Okay, let's look at this one. Now this one looks weird. His average is a 7. Tell me about the spread between these two. Well, normal distribution 1 is much more spread out than normal distribution 2. Okay, so let's see. Which statement best describes the two distributions? Normal distribution 1 has a higher mean. Well, normal distribution 1's mean is at a 5, and number 2 is at a 7. So that's false. He has a lower mean. Normal distribution 2 has a higher mean. I like that. And a higher standard deviation. Remember, standard deviation is the spread. So it's saying that distribution 2 has a higher spread, and that's not true. That data is much tighter than distribution 1. Normal distribution 1 has a higher mean. Nope. Normal distribution 1 has a higher standard deviation. So this one is much more spread out, and normal distribution 2 has the higher mean. Yes, 7 versus the 5. Which set of data would you expect to have the greatest standard deviation? So standard deviation is the spread. So I want the greatest spread. So I want my data to be really spread out. So it says the heights in centimeters of all the students in the first grade class at a large elementary school. Now first graders are not all the same height, but they're all short. They're all roughly 7 years old. They're in the same ballpark. Yes, you're going to have some variability, but not tons. The height in centimeters of all first grade teachers in the elementary school. Well, teachers are adults, can be anywhere from 22 years old to 100 years old, but they are all adults. Most of them have stopped growing. Now, yes, they're going to have different heights because grown-ups have different heights. So you're going to have some variability there, but not tons. C, the height in centimeters of all the first grade students and all the first grade teachers. All right, now you're talking. Now we've got some variability here because we've got first grade students, super short, and first grade teachers who are grown adults. So that's lots of variability. So I like C, he's a possibility. D, the circumferences in centimeters of the wrists for all the students in your class. Okay, well, look at your wrist. It's a pretty standard measurement on a person. And we're talking about all the students in your class. we're going to all have about the same wrist circumference. So I'm going to say that's not going to have tons of variability. E, the foot lengths in centimeters of all the teachers in your school. Well, there's some teachers got some big feet, and there's some teachers that got some small feet. But we are all teachers, which means we're all adults. So we're going to vary, but not that much. The most variation we're going to have is when you compare adults to students. Those heights are going to be all over the place. So that would have the greatest standard deviation or the most spread. Box plots for competing brick manufacturers are shown below. Which manufacturer has the least variability in their bricks? So I want the least spread out. That's going to be Daniel. Okay. Table below shows the population of several cities. What would happen to the data set if Tinkerton, with a population of 50,000, was added to the data? Okay, so to do that, I've got to figure out where who's going to land. So I'm going to get these in order. Okay, and then Tinkerton has 50,000, so that's going to be way over here. That's my new piece of data. So again, think of your curve. Okay, so would this cause the standard deviation to decrease? Well, no, I'm adding data way out there in the wings. That's going to make it more spread out. So my standard deviation would actually increase. Interquartile range, again, you can't tell anything about an IQR unless you have Q3 and Q1 from a box and whisker. The range decreases. All right, well, let's think about this. Remember, the range is very simple. It is the max minus the min. Well, we have now put 50,000 up here, so our max has just increased, which makes our range bigger. So the range did not decrease, it got bigger. The mean increases. Well, the mean is our average. Our average is right about here. We're adding data way to the right, so that's going to pull our average that direction. So yes, it's going to make my mean increase. Number of points scored by a basketball team in the first 8 games. All right, let's get them in order. Let's see, 46, 54, 58, 61, 62, 71, and 80. Okay, then I'm going to add to it a 42, a 59, a 62, a 63, a 65. Okay, so again, think of your curve. Now we put a lot of data here in the middle, so that's going to up the peak. But then I've also added this sucker out here, and so that's going to pull the spread out. So I'm thinking more peaked and more spread. More peaked, more spread. And those are just 2 more problems that you can try on your own.